Hi, my name is Jan Wilczek. I'm a founder of the Wolfsound blog and YouTube channel on audio programming. In the previous episode of this tutorial series, we learned how to iterate on your plugin's UI using a local development server. In this episode, we will see how we can provide, for example, audio, but also other kinds of data from the C++ backend to the WebView frontend, even if we're running a local development server. So in a way, it will be an extension or a deeper example of something that we've already done in the previous episode. As usual, the full code of this tutorial project is available on GitHub, and you can find the link in the description below. And now let's go with the tutorial. As you remember from the previous tutorial episode, we, in the constructor of our plugin editor, went to local dev server address, which in our case is simply this default localhost address. And this causes the WebView to display anything that's hosted under this local server. In fact, you can direct this to, of course, any URL on the web, but we're building here an audio plugin. On top of this, we allowed here with ResourceProvider, this local server to ask for resources specifically from the C++ backend. And as you can see here in getResource, if this specific resource requested by the plugin running on a local development server was equal to data.json, we then created some example JSON and sent it back to the frontend. In this episode, what we'll do is we'll provide some audio data, so data that can only come from the C++ backend to the frontend. And what we exactly want to do, we want to display on the UI a gain meter. We want to show how loud the input to our plugin is. And for this, there'll be one part, well, in the audio processor, we'll follow the envelope and we'll measure the gain level of our plugin. And then we'll expose this data in the plugin processor's API to the plugin editor. And the plugin editor, at regular intervals using JUCE's timer class, will emit a JavaScript event. This event, in turn, will cause JavaScript frontend to request a specific resource from the C++ backend, so not from the development server, but from the C++ backend, and then our C++ backend will return this data to the frontend so that the frontend can update it and paint it. So first, let's start with measuring the gain of our input samples, which is sometimes called envelope following. And for this, we use a specific class, namely BallisticsFilter from JUCE's DSP namespace. So here in the plugin processor, we'll declare our BallisticsFilter. So we'll use DSP BallisticsFilter, and our samples are float, so it's of type float, and we'll call this envelope follower. And then we'll declare another member, which will be an audio buffer, because an envelope follower needs to have a place to which it outputs its envelope samples. So for this, we'll have JUCE audio buffer float, and we'll call this envelope follower output buffer. Okay, but that's not all, because we also need to expose the measured gain value. So we'll create another mem, like this time it's gonna be public or atomic float output level, and we'll call it left to measure just the left channel. Here you could, of course, wrap it so that, the clients of the plugin processor class cannot change this value on their own. But for simplicity's sake, we'll just have a public member here, and it can be queried from the editor class because it's an atomic. So it's synchronized in a way that the operations on this float are atomic. So this is thread safe. Okay, for this class to work, the ballistics filter, we need to include JUCE DSP. So I'll go hashtag include JUCE DSP / JUCE DSP.h. And then we'll go to the plugin processor. And here we need to go to the prepare to play method, right? Because we need to initialize our ballistics filter. Okay, so here for simplicity, we'll using namespace JUCE. And then we can go envelope follower prepare. And as you can see here, we need a process spec instance. So we'll go DSP process spec, and we'll use this designed initializers here. So we can go sample rate assigned sample rate, and then we can go maximum block size to the samples per block, but we need to cast it because it's of a different type. So it's unsigned int 32, and we have samples per block here. And the last field is num channels. And here we'll pass what our plugin knows about as the total number of output channels. So we'll go static cast uin32 get total num output channels. Okay. And here we need a semicolon. And now we can set also some parameters of our envelope follower. So I'll set envelope follower, set attack time, and I'll pass here 200, which corresponds to 200 milliseconds. And then I pass envelope follower set release time. I'll do the same. And also set the calculation type to the peak. So we'll go DSP ballistics filter float level calculation type peak. And finally, we need to resize our buffer, right? Because in prepare to play, we can only allocate our memory. We should not do it on the audio thread. Get total num output channels. So that's our number of output channels. And then we'll simply go samples per block. Okay, so this is our initialization of the envelope follower. And these values, you know, they're completely empirical. If you want to use some other values, then you're encouraged to do so. And now we can measure the output gain of our plugin. So we'll go to process block. Okay, for now we don't have any processing. So this will be the same as the input gain measurement, but maybe later we'll add some more processing. So one thing we need to do, we need to prepare the block that will be processed to our envelope follower. So this will be JUCE, cons auto in block, JUCE DSP, audio block of type float, and we'll pass here the buffer. So the audio block is just a view of the data in the buffer. It does not allocate anything. And now we'll specify that we want to only have the channels of the buffer that we actually know that we're processing. So we'll go get subset channel block and 0u, so unsigned, and then static cast size t. And this will be get total num output channels. So as you can see, we need to perform some conversions of, you know, various integer types, but this is the bread and butter of C++. And then we need to define our output block, and this will be, you know, the buffer that we specifically designed for the envelope follower output. So again, we'll go JUCE DSP audio block float, and we'll go envelope follower output buffer, and we'll leave it like it is. And now is the time that we can process with our envelope follower. So we'll go envelope follower, process. And here we need to define that we want to put the output of our DSP processor into a separate audio block. So you can have process context replacing that will do the processing in the same block that you pass it to. And you can have process context non-replacing that will take samples from one audio block and will output them to another. And here we have a specific output buffer that we want for our envelope follower to output its result to. So that's what we'll use here. So we'll go once again, JUCE DSP, process context non-replacing, and this is of type float, and we'll pass here in block and out block. Okay. And once we've done this, then now we want to read out the envelope value and we want to transform it to decibels because that's something that people are used to see on a plugin UI. So we can already assign it to our output level left member. So I go output level left, and this assigns to this atomic float, JUCE decibels, gain to decibels. And here I'll take the last sample of envelope follower output. So I'll go out block, get sample, and this is taken from the first channel. So from the left channel, that's my assumption that there are two channels, and we'll take from the first one. In any way, this should be always valid, right? Because there's always at least one channel. And then we go static cast. Maybe let me scroll this up a little bit. Static cast. And we'll go int and then out block get num samples. So -1. So this will be the last sample in the first channel. And maybe let me format this. Okay. Now it's nicer. And that's basically everything we need to do in our audio processor. So let's compile this. Okay, as you can see, we got a linker error. And that's quite a good news, actually, because it means that our code compiled. It just did not find the right symbols, and we can easily remedy that. So let's go to the CMake list that contains the definition of our plugin target, and let's scroll here. Okay, as you can see, we are not linking to JUCE DSP module, so we can easily fix this. We'll go JUCE DSP in the private section of target link libraries. Because the fact that we link to JUCE DSP is an internal fact of our processor. So once again, let's reconfigure this project and build it again. Okay, as you can see, our project built just fine. So now it's time to add the necessary code in the plugin editor. So once again, we want to have our plugin editor publish a specific JavaScript event at regular time intervals. And for this, we need to make the plugin editor inherit from the JUCE timer class. So go here and we'll specify that it's a private inheritance. So it's private JUCE timer. This timer class has one virtual function that we can override. So it's this timer callback. So I'll copy to our plugin editor. And I'll make this as override. And this will be called as often as we want, more or less. So let me go to the plugin editor. And here we want to implement this function. I'll do it under resized. So that's it's analogous to what's in the header. So let me use this class and now timer callback. Okay, and the only thing that we'll do here is we'll emit this specific JavaScript frontend event. So we'll go JUCE WebView emit event if browser is visible, and we'll call it simply output level. And we don't want to pass any value here. So we'll just pass an empty variant. Of course, we could pass here the output level, but for the sake of this tutorial, we want to do something different. Namely, we want to just retrieve a specific resource from the C++ backend, even if we have our localhost development server. Okay, and the last thing that we need to do on our C++ code, we need to start our timer callback so that this handler gets called at regular intervals. So in the constructor, we can go start timer, and here we pass in the number of milliseconds that the interval should be made of. So in our case, it's 60. So every 60 milliseconds, this callback should be called. So let us build this again. Okay, we managed to build our plugin. So that's everything we need to do on the C++ side for now. But I can spoil already that when the frontend will ask for the output level resource from the C++ backend, we'll have to change this get resource function. So now let's move to our JavaScript frontend. Okay, we want to attach the JavaScript frontend to a specific event. We want our JavaScript frontend to listen to specific events. And we can do it, for example, here in this function that gets executed after the whole UI has been loaded. And how we can do this? Well, we need to access the JUCE backend in JavaScript. So we go window __ JUCE __, then backend, and we'll go add event listener, and we'll specify the same event as we defined in the C++ backend. And now, there are no arguments in this handler. So that's one level that we have here. And now what we want to do if this event happens? Well, we want to fetch the resource from the C++ backend. So we're going fetch, and here we don't just specify, any resource from the backend. Well, specifically, we have to define that we don't want to ask our localhost server. We want to ask the C++ backend. So we're going to write juice.get backend resource address, and we need to pass here the name of the resource that we want. So let's say we want to have output level.json file. So we expect that we'll get a JSON file. And then we can specify continuation. So we'll go, then we get some response. And from this response, we get its text. Okay. And then we have the output level as our text. And now we can specify the function that parses this output level. And for this, we can simply use JSON parse. So we'll go const level data, assign JSON parse output level. So that's the text that we received in the response. And what we'll do for now, we'll simply console log this level data. So now we need to start our local server. So for this, let me open the console again, and let me cd into plugin, UI, and public. And here are start the local server using HTTP server package from Node.js. Okay, as you can see, the server is available under this link. So what is served by this local server will be displayed in the WebView UI. So now let's run our plugin. Okay, I'm on Windows. I'm using the MSVC toolchain. So for me, the standalone is in build plugin, JUCE WebView plugin artifacts, debug standalone, JUCE WebView plugin.exe. So let's run this. Okay, as you can see, here's our plugin. And as you can see, it requests output level.json from the C++ backend constantly, which we are printing here in get resource. But if we open our development console, as you can see, we get for the output level.json, we get error name not resolved. That's because from the C++ backend, we return nullopt, right? We're not handling this output level.json. So that's what we'll work on now. So here in our resource provider, we can intercept the request for the output level.json. So once again, the front end asks for all the resources, the development server, unless we specify that there are some resources that we want to explicitly get from the C++ backend, and that's such a case. So we need to check resource to retrieve. If resource to retrieve equals output level.json, then we can provide our handler here. So this will be very similar to what we had here before. So I'll just copy this. So we're creating a dynamic object via a pointer. Then we set its property, and I'll set just one property. It will be left. And the left property will be from processor reference, processor ref, output level left, load. Right, so we set the left field of this output.json, and then we convert it to a string, and then we convert it into a memory input stream, and finally we change this input stream to a vector, and we return it to the front end using the application/JSON MIME typed. So now I changed the C++ backend, I need to recompile the plugin. Okay, let's run our plugin. Okay, as you can see, I'm still asking for this output level.json, but now when we go to inspection and we check out the console, we get left -100. So we get -100 decibels in the left channel. And now if I carefully enable audio input, which will come from my microphone, we'll see that this level changes. Exactly. You can see that for a while it changed. I need to be careful because otherwise I'll get a feedback. Okay, that will be it. Of course, we can always test it in a digital audio workstation, but for now I wanted to show you it here. Okay, but we're still not doing anything, right? We're just logging this to a console. We would like to, of course, have a nice plot of this data. We have to have nice meter. So for this, we'll explore another neat feature of WebViews. We can use third-party front-end libraries to paint our content. So for this, I decided to use the Plotly.js library, and this can be easily imported as a module. And we need to do it in the HTML file. So we'll go here, script, src. And here I'll just copy and paste what is instructed in the Plotly.js tutorial. And I need to specify the character set, charset UTF-8 /script. So that should import the Plotly library in our UI. And now we can create our plot. So we'll again go to index.js. And here, before we subscribe to this event, we want to create our plot. So I'll just write plotting with Plotly. Okay, and here we go, Plotly, new plot. I will call it output level plot. And for this, we need to have an element, a div, an index.html that has exactly the same ID. Output level plot. Exactly. And inside this div, we'll plot our plot. So here we go. We have data, and we have just one series of data. So we'll call this left. X will be left. And then Y will be -60, for example. And then the base we specify again as -60. Actually, I can put it in a variable. So we'll go const base -60. And then we'll go type. It will be a bar plot. And that are all the data series in this array of data. And then we need to specify the layout. And here I'm just passing some values, which of course you can change. So the width is going to be 200, height is going to be 400, y-axis is going to have range from the base to 0. And we need to terminate the parentheses here. So I'm terminating with semicolon, and now I need to write here a colon. Okay, and I have here one extra closing parentheses. Okay, so that should create our plot. So because we're on a live server, we can just run our plugin. Okay, let me refresh this. Exactly, we downloaded the Plotly library, and here we have a nice plot already. But of course, we're not plotting anything because we have not changed the handler here. So let me maybe quit the plugin for now. And here we'll animate the plot. So what we need to do, instead of logging this, we'll go plotly.animate. And we need to again specify output level plot. And here we pass what's changed. So the data changed, but only the Y. So we'll go level data left. So we're reading out the level data from this JSON. We need to shift it because that's how Plotly works. So we'll just subtract the base. As remember, base is -60, so that this will add 60. And I need to terminate this, and to specify the traces to 0, and layout will be the same. And now I can specify the transition here. So I'll go transition. So that's nice and smooth. Duration will be 20 milliseconds, and then the easing will be cubic in out. And we can also specify frame and its duration, which also going to be 20. Now I hope I closed all the braces here and brackets. This seems fine. Okay, here I need a semicolon. Okay, this seems fine. So let's again start our plugin. We don't have to recompile anything. And as you can see, nothing is shown because, as you remember, we get just -100. But if I allow audio for a second, you'll see that we have an animatable gain plot. And as you can see, as when I speak, this gain meter goes up, and which means that I'm retrieving the gain input level from the C++ backend. And what you need to remember, if that your UI does not reflect the changes that you made, you always need to do a hard refresh. So on Windows, it's Ctrl-Shift-R, and on Mac, it's Command-Shift-R. But that's essentially our output gain meter. And what's nice that it's so reactive. I can zoom in, right? I can zoom out. And that's how you can see the base here. And of course, you can tailor it to your liking. But the awesome part is that I've just used a JavaScript frontend library to create part of my plugin's UI. So let's recap once again what we did in this episode. We're running a HTTP server that hosts the UI of our plugin. When our plugin is started, it goes to this local development server, and this is what you can see here in the constructor of the plugin editor. Go to URL, local dev address. When we have native integration enabled, we can interact between C++ and JavaScript. And now, when we have our local development server And when we specify with ResourceProvider, we also specify that this host can ask for C++ resources. So our UI can say that it wants specifically a certain resource from the C++ backend. So not from the server, from the C++ backend. And what we did in this episode, we created an envelope follower in the plugin processor that follows the envelope of the output samples of our plugin and calculates its decibel level. And then our plugin editor, at regular intervals specified in the constructor, has its timer callback called, and it emits a front-end JavaScript event with output level. And our JavaScript frontend listens for this event, and when it happens, it retrieves this output level as a JSON. And this we need to handle in our get resource. So once again, in JavaScript, here with JUCE get backend resource address, we specify that we want the resource to come specifically from the C++ backend. And in plugin editor, we handle this in the get resource. So we check, okay, is it output level JSON? And if it is, then we read out this property from the processor, write it to a JSON that we then return to our front end. And once again, on the front end, we parse this response to a JSON file, and then we output our output gain plot, which we created using third-party JavaScript frontend library, in this case, Plotly. So in this way, you can see how to easily, ask for resources from the server and ask for resources from the C++ backend specifically. So we get all the benefits of hot loading, but we can still use the C++ backend. And this would also work in a digital audio workstation. And I highly encourage you to check it out in a digital audio workstation and also to debug the calls that happen in the background. Thank you for watching this tutorial episode. The link to the repository with the source code is in the description, so I highly encourage you to check it out if you're curious. And if you have any questions, if you have any comments, please put them in the comment section below or on the JUCE forum. I highly encourage you to subscribe to this channel and to the Wolfsound channel, and I see you in the next tutorial episode where we look how to control plugin audio parameters from the WebView UI frontend. So stay tuned for this. Thank you for watching and take care.